One of the world's most renowned and forward-thinking physicists, Michio Kaku, has recently shared his thoughts on a discovery that's causing major waves in the scientific community. Known for his significant contributions to physics, Kaku has acknowledged that the James Webb Space Telescope has identified six enormous galaxies that defy current scientific expectations. These findings could dramatically reshape our understanding of the universe, making them a fascinating development to observe closely. Michio Kaku, an American physicist of Japanese heritage, stands out in the scientific world not only for his expertise in classical physics and quantum mechanics, but also for his openness to new discoveries. Unlike some of his more traditional peers who are hesitant to embrace unexpected results, Kaku has welcomed the extraordinary data coming from the James Webb mission. His public response to the discovery highlights just how impactful these revelations are. He expressed genuine excitement, calling this one of the most captivating moments in recent space science. Throughout his career, Kaku has remained open to revolutionary ideas. He understands that the current frameworks we rely on, like Newton's laws and Einstein's relativity, might not be sufficient to fully explain the complexity of the cosmos. This latest discovery, he believes, could offer a richer understanding of the universe, even though many other scientists are still reluctant to accept its implications. The data is stirring unease, especially among those who support the conventional Big Bang model or are deeply rooted in traditional quantum mechanics. While some are troubled by these results, Kaku seems to welcome the challenge with curiosity and even amusement. The James Webb Space Telescope has revealed six enormous galaxies that appear to date back to the earliest periods of the universe, just 200 to 700 million years after the Big Bang. Each of these galaxies contains more stars than our own Milky Way, despite their incredibly early formation. The team of astronomers who discovered them have dubbed them universe breakers due to their potential to overturn long-held scientific theories. If these observations are confirmed, they could force a major revision of our understanding of cosmic history. This finding contradicts the widely accepted timeline of the Big Bang theory, which holds that the universe was a chaotic plasma shortly after its inception. According to this view, it took hundreds of thousands of years for the first atoms to form, and many millions more for complex structures like stars and galaxies to emerge. Under those assumptions, massive and highly organized, galaxies shouldn't have existed so early in the universe's timeline. Yet, some of these newfound galaxies not only match but exceed the Milky Way in size and star production, creating hundreds of stars per year, while our own galaxy forms new stars at a much slower rate. The actual moment when the first galaxies formed remains unknown. Until now, it was believed that the early universe consisted mainly of individual stars, or small groups of stars that gradually merged to form dwarf galaxies. Over time, these smaller structures collided and combined to become larger galaxies. According to previous theories, galaxies of the size and complexity seen in these Webb discoveries simply shouldn't have existed so soon. This forces scientists to question whether the universe is much older than previously believed, or whether galaxy formation occurred far earlier than expected. These possibilities are difficult for many in the scientific community to accept, and some have strongly challenged the findings, suggesting potential errors in calculating the galaxy's ages. Kaku is aware of this resistance. He has pointed out that science has often clung to outdated theories because of the reputations of the scientists behind them. Many of these ideas persisted until key experiments finally disproved them. That's why, according to Kaku, experimental science plays such a critical role in keeping theoretical science honest. He also emphasized that our knowledge of the universe's origins is still extremely limited. The Big Bang theory, introduced in 1927, was based on observations that the universe appears to be expanding outward from a single point, At the time, the notion that the universe had a beginning and might also have an end was a radical concept. Most people believed the universe was eternal and infinite. Even now, many scientists struggle with these ideas. The latest data challenges decades of assumptions about the Big Bang, pushing science once again to reevaluate its foundations. But this is not a new phenomenon. Scientific understanding has always evolved through the process of challenging and testing accepted ideas. For example, there was a time when people believed the stars and planets were fixed in the sky. Now we know that everything in the cosmos is in constant motion. Planets orbit stars. Stars travel through galaxies, and galaxies themselves race through space at astonishing speeds. Today's scientists are being asked to face uncomfortable truths. Theories remain only hypotheses until they are tested and confirmed by observation. The Big Bang Theory gained ground when astronomers discovered that galaxies are moving away from us, and that this motion is proportional to their distance, a relationship now known as Hubble's law. Supporting evidence like cosmic background radiation and the red shift of light from distant galaxies seem to confirm this view. Yet it's worth remembering that in the past, people also had what seemed like solid evidence for believing that the Earth was flat or that the Sun orbited around it. It wasn't until better technology and methods became available that these misconceptions were corrected. Now, with the James Webb Space Telescope revealing galaxies that challenge the very foundations of cosmology, we may be at a similar turning point. Scientists had hoped the telescope would provide confirmation of the Big Bang model. Instead, they've encountered something that doesn't fit. Galaxies that seem impossible based on current timelines. This reminds us that science is not static. It's a constantly evolving pursuit, and researchers must remain open to re-evaluating theories when new evidence demands it. A key tool in this kind of research is redshift, also known as the Doppler effect, which allows scientists to measure how far away celestial objects are and how fast they're moving. Redshift refers to the way light changes color depending on its motion relative to the observer. For example, as a car approaches, the sound of its engine seems to rise in pitch and then drop as it moves away. The same principle applies to light. If a star or galaxy is moving toward us, its light shifts toward blue. If it's moving away, the light shifts toward red. Physicists use redshift to convert these color changes into data about speed and distance. But even small errors in redshift measurements can have a significant impact on conclusions about the universe. The methods used in these calculations are now being scrutinized more closely than ever. It remains to be seen whether these new discoveries are the result of errors in redshift interpretation, or whether some in the scientific community are simply unwilling to accept a new reality. What's clear is that this moment calls for rigorous examination of the data and a willingness to question even our most cherished models of the universe.